Today we're talking about natural base E. We're going to define and use the natural base E, graph natural base E functions, model continuously compounded interest. So that's what we can use it for. The natural base E is an irrational number. It is defined by the following equation. So as x approaches positive infinity, so if we're looking at our graph, as x continues to increase, the function 1 plus 1 over x quantity raised to the x power approaches E, which is approximated at 2.718. And usually when we are estimating that, if we use our calculator, we'll stop there, 2.718, maybe 2.7182. But the reason that that's important is because, we use it for compounding continuous interest. So when we compound continuously, that's the function that we'll use. So this is still an exponential function, but our base in this case is going to be E, which is at 2.718. And we can see that we have two functions. We have exponential growth with natural base, and we have exponential decay, which is down here. So we still, for both points, we still have the point 0, 1. So that's going to help us graph. And then we can see that we have negative 1e. So if we go back 1 up e, so e again is 2.718. Or if we're looking at exponential growth for the parent function, it will be 1, 2.78. So for exponential growth, everything's the same except for the r value here when we substitute it in is positive. And if we look at the exponential decay down here, the r value is negative or less than 0. So here's a graph up here of the approximation of E, and we can see that we have the asymptote here of y equals E, which is again 2.7182. And as we're going farther and farther and farther to the right, as x is getting bigger, we're going to get closer to that 2.718, but we won't ever cross it. So even here at 10, we're at 2.6, and then it'll continue to increase. And as we get to infinity, as we try to get closer to infinity, that will get closer and closer. I'll shut those off. Now we have the parent function of the natural base E exponential function. So we still have the point 1, 0. Actually, I'll turn this one back on. And then we can see if we go over 1 up 1, we get to 1, 2.718, or that's where it crosses the value of E. And remember, anything raised to the first power is itself, so that is 2.718. Same thing if we look at the exponential decay function. That one also is going to cross at negative 1, 2.718. And they both intersect the graph at 0, 1.